Hello. Now I am starting the experiment of salt analysis. I am taking a pinch of the salt in my test tube. I will add some concentrated HNO3 into this solution. It will get dissolved into this concentrated HNO3 solution, and now I will add silver nitrate solution, and I will get the white precipitate. If we are getting the white precipitate, you can see it is the white precipitate. It will indicate chloride minus ion is present in our salt. So this is the white precipitate of Cl minus. Basic radical, I will take the pinch of salt in my test tube. Now I will add some water into it. 2-3 drops of water. And now I will add NaOH solution. This is NaOH solution. We can smell it by heating it. NH3 gas, ammonia gas will evolve. So we can smell it. Here is the smell of ammonia gas. Now I am adding Nessler's reagent. 1 or 2 drop of Nessler's reagent only. So the brown coloration here is brown coloration which indicates the zero group presence, and NH4 plus ion is present in our salt.
We'll start the preliminary test. We have taken the salt. You can see the texture of the salt. And then we can add a slight amount of water into it. Just rub it out. Dip your glass rod and bring it nearer to your nose and smell it, whether it is giving a acetic acid, vinegar-like smell or not. So this is being done. Now dry heating test. So we'll take a slight amount of salt in a dry test tube and we'll heat it up. And while heating, please take care that your test tube should not be in much contact of the flame. Otherwise, there's a chances of explosion. So while heating it up, you can bring the moist litmus paper over the mouth of the test tube. And if it turns red, that shows the presence of acid in this. Acetic acid is an organic acid. So that's a weak acid. So you can see the coloration of a litmus paper. To undergo the indicatory test now, so this is concentrated sulfuric acid. I'm going to pour a slight amount of concentrated sulfuric acid in our salt. Take care while heating it up. And while heating, it will start evolving acetic acid vapors, and we can see the presence of acetic acid vapors with the help of a blue litmus paper. So we have a blue litmus paper, moist blue litmus paper with us to see whether it's showing any change or not. You can see the blue litmus paper turned red. That shows the acidic vapors emerging. So we are moving towards the confirmatory test of an acetate ion. So this is the first is oxalic acid test. We'll take a slight amount of our salt and then same amount of, so we'll take a same amount of an oxalic acid and we'll have a drop of water in it that is distilled water, and then you make a paste with the help of a glass rod. And then dipping the glass rod in a paste, you can just have a smell of it. It is having a strong smell of vinegar that shows the presence of an acetate ion. Okay. So the next test is ferric chloride test. We have taken aqueous ferric chloride solution. We will take a slight amount of this, and then we'll neutralize it, and neutralize it with the help of ammonium hydroxide, the base. Ferric chloride is a Lewis acid. So it will be neutralized by ammonium hydroxide, and it will create a brown precipitate. A brown precipitate in this manner. So that means it has been neutralized now. We'll take a salt, and then we'll add slight amount of water in this. So it forms an aqueous solution, and then after mixing it well, you have to add neutral ferric chloride into it. Gives a brown precipitated solution which you have to filter. So the funnel with the filter paper, filter it up. Stop. We'll take one part of that filtrate. This is the filtrate which we obtained. We'll take one part and we will add dilute hydrochloric acid into this. So if the color disappears, it shows the presence of acetate ion. See. We'll take the second part, add a slight amount of water in it, and then we'll start boiling it up. On boiling, it should give a brown precipitate. So if it forms a brown precipitate, that shows the presence of an acetate ion. And so you can see the presence of a brown precipitate, and that shows the presence of an acetate ion in the salt. Okay, so we are moving towards the confirmatory test of our lead ion. Salt plus water. Prepare an aqueous solution. And then the group reagent, because it is a group first cation, so the group reagent is dilute hydrochloric acid. So when you add the group reagent, you can see precipitation formation. See. That confirms the presence of a group first cation, that is lead ion. It sediments easily when you dip it in a cold water and keep it for some time. So I have divided it into two parts, and to first part I'll add potassium chromate, which make it turn yellow, dark yellow golden coloration. That's lead chromate formation. When you mix it well, you'll get the whole solution in the same color. Then to the second part, I can add slight amount of potassium iodide. And potassium iodide turns the whole solution light yellow. And this is a reliable test because you can see potassium iodide is colorless in nature. So when it came in contact with the solution, it turned it yellow. So you can see the color difference now. One is a dark orange coloration, and the second one, that is of potassium iodide, is a light yellow coloration. So this is the confirmatory test for lead ion, the formation of a lead chromate as well as lead iodide. Reaction equations related to our test, analysis of the lead ion. So we were having lead acetate with us, and we added hydrochloric acid into it. So white precipitate formation took place, and that's lead chloride. Then we undergone confirmatory test of lead ion, and we have undergone potassium iodide test, and in that case lead chloride, that means a white precipitate which has been subdivided into two parts, To the first part we added potassium iodide and it gave yellow precipitate of lead iodide. The second test was potassium chromate test where the lead chloride, the second part of the white precipitate is being treated with potassium chromate. It forms lead chromate, that was orange yellow precipitate. Then indicatory test, concentrated sulfuric acid test. We took our salt and we treated it with concentrated sulfuric acid that gives acetic acid vapors. And we dipped the blue litmus paper and brought it towards the mouth of the test tube and it turned red. That was because of those vapors. Oxalic acid test, formula of an oxalic acid, treated with our salt, formation of a vinegar-like smell vapors, that is acetic acid vapors. दो equations और हैं उसके बाद में remaining equations. Ester test, lead acetate, concentrated sulfuric acid turns into lead sulfate and it evolves acetic acid, and that acetic acid will be treated with ethyl alcohol in order to give ethyl acetate as ester. It is having a fruity smell. So our last test is ferric chloride test. We have taken aqueous solution of our salt. We treated it with neutral ferric chloride. And how to utilize the ferric chloride solution? We have an aqueous solution of our ferric chloride in our laboratory. We'll add ammonium hydroxide as a base. Ferric chloride is a Lewis acid, so it will be neutralized with the help of ammonium hydroxide and it gives a brown precipitate. That brown precipitate shows neutralization reaction. So that neutral ferric chloride is being added to the aqueous solution of the salt and then it is being converted into ferric acetate. That ferric acetate has undergone two reactions, and out of that one reaction was when it is being added with water and boiled, it forms a reddish brown precipitate, and that was the complex. Result is acidic radical, that was the anionic part was acetate ion, basic radical lead ion.
Good morning students. In today's class I will be talking about the tests for lead. Lead belongs to group number 1 of salt analysis. Lead 2 positive is the ion that we test, and this is the salt that I have taken. Lead nitrate is the commonly available salts in all the chemistry labs of 11th and 12th, the senior chemistry lab. The salt looks white in color. This lead is your white colored salt, and white because it is not one of the D block elements. So this is your salt. To this salt you will add water to dissolve it. Please pay attention, for lead salts it is only distilled water to be used. Tap water cannot be used because tap water itself has chloride ions, so you will get a white PPT of chloride. I'll just show that to you. This is my distilled water and I get a clear OS. That is my original solution which I'll be using. Now in case I try the same thing with tap water. This is the salt and this is my tap water. You would never get it cleared. So the lesson learned, tap water not to be used for lead salts, you will only use distilled water. Now second step, going to the first group reagent. The group reagent for first group is dilute HCl. I add dilute HCl to it. Closely have a look at it. You get a white PPT. Indicates presence of group 1 which is lead. A white PPT with dilute HCl indicates presence of lead. Now, after this point, you would heat this solution. Always heat it in a slant manner so that this doesn't bump, and keep moving it away from the burner for avoiding the bumping. What I need you to observe is what is happening when you heat the contents. On heating the contents, you will observe the amount of precipitate will decrease. Since in this case the precipitate is large in amounts, so some of it gets dissolved. Normally, if the lead salt that you have used is less in amount, it completely clears up on heating. Let me add a little bit of water to facilitate the dilution. Okay, you can see this is getting clearer and it will completely dissolve. So when you heat the salt, which is formed, that is your lead chloride, white PPT, it dissolves in water, as you can see. Once dissolved, now you will be doing the confirmatory test. The first confirmatory test is you take a part of it and leave it for cooling, because it would reappear. You would observe that the precipitate gets reappeared when you keep it for cooling. Have a look. It has started to reappear. The clear precipitate starts to reappear. I just took a part of it and you can clearly see the precipitate is settling down again. That is one test. Heat it, it dissolves. Cool it, it reappears. Now I am taking it into two parts. For lead, this hot solution, I have taken it into two parts. To first part, I am adding potassium chromate, the reagent that you also use for barium. Confirmation, potassium chromate. It's chromate, not dichromate. It has just one Cr in it. Adding potassium dichromate, a yellow colored solution, to this dilution, you get a yellow PPT, which is called as your canary yellow PPT of lead chromate. That's the first confirmatory test. Moving on to the second confirmatory test, I am using the second half of the solution which I just dissolved, and you are supposed to add potassium iodide solution. This potassium iodide solution, when added, leads to again a yellow color, but this yellow is slightly on the darker side, and this is called as also the chrome yellow, and this is yellow due to lead iodide. I'll give you a quick recap. We took a salt, dissolved it in normal tap water, did not dissolve. Then we took the salt, dissolved it in distilled water, heated to clear the solution. You can have a look. This is the solution that I was talking about, and it got cleared when you heated it, beyond which I kept some of it, left it undisturbed. It's clear. If I leave it after some time, I will find the precipitate reappears on cooling, which means the solubility is low. After that, we took two parts of it. To one part I added potassium chromate, and the other part I added potassium iodide. In both the cases, you get a yellow PPT, and that confirms lead. For any other reference, there are all these salt analysis done in the channel. You can keep referring to the channel for any cations where you get stuck. One more thing, one last thing which you should know. This is the OS that I was talking about. I'm not cooling it right now because I showed it to you that on cooling it does reappear. In case you add H2S to this, what would happen? What happens is, in case of H2S, I am using Na2S, you would again get a black PPT. Lead gives you a white PPT with dilute HCl and gives you a black PPT with Na2S. This can work as a third test. That means you have potassium iodide, you have potassium chromate, and you have Na2S. There are three tests for lead. But the part of confusion is that how do you say it is lead? Because I also showed you a black for copper in the last video. Copper black and lead black both are formed, but you can easily identify because your copper salt is going to be blue in color while your lead salt is going to be white in color. So if a white salt gives you a black PPT with Na2S, in case of the second group analysis, it is lead, otherwise it is copper. Fine. I hope I have cleared your tests for lead and confirmed the difference between copper and lead. With this, I close my class. I hope that I am trying to clarify your salt analysis for your practicals so that you're not scared anymore of the chemistry practicals. All the best. Do well, kids.